Hi there and welcome to Code Framer. Welcome to the brand new section in this course. In this section, we will learn about recursion. So let us first understand why it is important to understand this concept. Recursion is one of the most important concepts in computer programming. If you understand recursion, then you can also learn how Python interpreter uses the stack-based execution flow to execute the function. In terms of interviews, most of the recruiters will ask you multiple queries related to recursion, just to test your understanding about recursion, and also to test your ability to think recursively and solve the problem. Hence it is very important to understand this topic, and also during this course, I will share most common questions which are asked during interviews with the solutions. So having said all that, let us move forward and start this video. So first, what is the meaning of the word recursion? Whenever we repeat certain steps, over and over again to reach a conclusion, then this process can be known as recursion. Let us see a real-world example of this, so that we can relate our real-life experience with this concept. I am sure that in your childhood, you would have seen this Russian doll, or you might have even played with it. So when you buy a Russian doll, you will get the largest doll. Now when you open the largest doll, then you will find the second largest doll inside the largest doll, so you can take out the second largest down and open it. Now you will find the third largest doll, and you can take that out. Now when you open the third largest doll, then you will find the fourth largest doll inside it. So basically if you continue to perform the same set of actions over and over again, until the smallest Russian doll is found, then this can be known as recursion. So here, when the smallest Russian doll is found, which cannot be opened anymore, then basically the recursive process has stopped. This is how you can visualize recursion in the real world. So having understood about recursion from real-life experience, now let us see the definition of recursion in the world of computer programming. So when it comes to computer programming, whenever a function calls itself, then this process is known as recursion. Or whenever we repeat a set of actions, until a conclusion is reached, then it can be known as recursion. I hope that this is clear. So before diving deep into recursion, first let us see why we need recursion. The first and the foremost reason is that, the recursive thinking is extremely important in programming, because it helps us to break down a large problem into smaller chunks. And sometimes the recursive solutions can be simpler than the iterative ones. Secondly, recursion is widely used in data structures like trees, graphs, and also some of the sorting algorithms. When recursive coding is compared with the iterative way of coding, then you will always find that the recursive-based functions are easy to write, as it involves fewer lines of code. So at this point you can ask a question, if the recursive way of coding is better in so many ways, then can we always write recursive functions instead of iterative loops? The answer is no. Because, there are many occasions when iterative loop performance is much faster than recursion, which means it purely depends on the situation. So now the next question is, when can we choose recursion over an iterative solution? Whenever you can divide a problem into similar subproblems, then you can choose recursion. Please note that the important point here is that the subproblem should be similar, otherwise we cannot choose recursion. The best way to identify whether a problem should be solved recursively or not is to do a lot of practice. But before practicing recursion, you must clearly know the difference between recursion and iterative loops. So let us have a look at the differences between recursion and iteration. The first difference is, when a function calls itself over and over again, until a conclusion is reached, or the base case is reached, it is known as recursion. Whereas, when it comes to the iterative loop, a set of instructions is repeatedly executed until the break condition is reached. The second difference is, the recursion is applied using repeated function calls, and the iterative loop is applied using for or a while loop. The third difference is, as in both the cases, the number of recursions or the iterations should not go to infinity, we need some condition to break. When it comes to recursion, we write a base case, which helps us to come out of the recursion, and when it comes to an iterative loop, we write a break condition, which helps us to break the loop. So the base case in case of the recursion, and the break condition in case of the iterative loop, helps us to stop the repeated actions when that is no more required. This is extremely important because not providing the base case or break condition can probably crash your system, which is extremely risky. So we must always ensure to provide the base case when it comes to using recursion. The fourth difference is, recursion can be used when you want to write a small amount of code, and also when the increased time complexity is not your concern. Sometimes you may be required to write a code with fewer lines of code, and also you can compromise a little on the time complexity of the code. In such cases we can always go with recursion. But on the other hand, if you want to write a code which must be optimized in terms of time complexity, and also you can write some extra lines of code, then we can go with an iterative solution. The fifth difference is, when we use recursion, we can write a code in fewer lines, but in an iterative loop, we may have to write some extra lines of code. The last difference to keep in mind, is also related to the time complexity of both the cases, because time complexity directly impacts the system or the application performance, which eventually has an impact on the user experience of your application. So always remember that recursion will always have high time complexity with large amounts of input data, and generally the time complexity will increase exponentially. Whereas, the iterative solutions tend to have lesser time complexity, which increases polynomially for large amounts of input data. I hope that the differences are clear. Don't worry if you have not understood some of the differences now, as we will look at many examples of recursion in the upcoming videos. For now, let us continue further and understand how we can write code in recursion and how it basically works. So the first thing to understand is that whenever we write a recursive method, the most important thing to take into account are these two conditions. Number one is to think about the method which calls itself with smaller values, and the second condition is to think about the exit condition or the base case with which we can come out of the recursion. So taking these two conditions into our account, a general algorithm to write any recursive code will look like this. As you can see here, this is a pseudocode which represents a recursive function. So the recursion method can take one or more than one parameters as input, and then if the exit condition, or the base case, is satisfied, then the result is returned as output, but if the base case is not satisfied, then the same recursion method function is called, but with a modified parameter value. This modification of the parameter value is extremely important because, if it is not modified, then the function will get executed over and over again, which will become an infinite recursive calls. It will be clear once we see the examples. For now, I hope that this simple recursive algorithm is clear. Now let us dive deeper into understanding recursion and how it works in the background. But before understanding recursion, you must understand how function executions work in the background. So in this example, as you can see, we have four functions. First method, second method, third method, and the fourth method. On the right side, we have a memory stack, which will help us to understand how these function calls are handled by the memory. So now, the first method calls the second method, and then it prints out, I am the first method. And then the second method calls the third method, and it prints, I am the second method. And the third method goes on to call the fourth method, and it prints, I am the third method. And finally the fourth method prints out that I am the fourth method, and this time it does not call any other method. So now let us see what happens in the stack memory when we call the first method. The stack memory is used by the system for sequential invocation of all the dependent methods. So a stack data structure works on the principle of last in first out method, which means that the last element which comes into the stack is removed first from the stack. We will learn about the stack data structure in detail in upcoming topics in this tutorial. So now let us go back to the topic. In the first method, we are calling the second method, which means that before completing the execution of first method, the interpreter will have to go to the second method, and once the second method execution is completed, the interpreter will have to execute the last statement in the first method, which is print, I am the first method. So this clearly means that the system needs to store the first method somewhere, so that when the execution of the second method is completed, it can come back to the first method to complete its execution. So when the second method is called inside the first method, the system will push the first method into the stack memory. In this way, the system will remember that it has to come back later and execute the first method. So now the second method, again calls the third method, which means the system will have to come back to the second method later, after executing the third method, which means that it will store the second method into the stack memory. Same action will be taken to the third method as well, as it also calls the fourth method. Now when the interpreter reaches the fourth method, it simply prints the statement, and this time it does not call any other method. Which means that the system does not need to come back to this method later, and hence it won't be pushed to the stack memory. So after completing the execution of the fourth method, the interpreter will again go back, and complete the execution of the third method. For this, it will look for the last element which was pushed inside the stack memory. As you can see, it is the third method. Now the print statement of the third method will get printed, and the third method will be popped out of the stack. The next method in the stack is the second method. Now the print statement of the second method will be executed. Once it is executed, the second method will also be popped out of the stack, and finally the first method will be executed by printing the print statement of the first method, and it will also come out of the stack. So once the stack memory is empty, the execution is completed. I hope that this is clear. For now, spend some more time with this flow and visualize this entire concept in your mind multiple times, so that you are always clear about this concept. In the next video, we will see how the recursive calls of functions are stored in the stack memory, and how the execution is carried out by the interpreter, when it comes to recursion. If you like this video, then hit the like button, share it with other code lovers, and subscribe to Code Framer for more videos. Thanks for watching and see you in the next video.